Hi there, grade 9s, and welcome to lesson 3 on the periodic table. The last couple of lessons talked about an atom and what it was made up of, protons, neutrons, and electrons. Then we went on to draw Bohr models of the atom, so these are representations of the atoms, and we figured out that protons had a positive charge and they went in the nucleus. Neutrons had no charge, we say they're neutral, they're also found in the nucleus. And that electrons with their negative charge are found orbiting the nucleus like planets orbit the sun. Each of those orbitals or rings can hold a specific number of electrons. The first shell closest to the nucleus can hold 2 electrons, the second shell can hold 8, and the third shell can hold 8. After you did your assignment on atomic basics, we started to look in the questions at the periodic table and some of the trends that we saw. If you can take a second and pause the video now and make sure you fill in these terms to know on pages 3 and 4 in your booklet. So now that you've filled in the terms periodic table, family and group, period, alkali metal, alkaline earth metals, chalcogens, halogens, and noble gases, we're going to get into how the periodic table is arranged. So if you can make sure you're filling in these notes in your booklet as we're going through this. So we've looked at the periodic table. We know that it's made up of different kinds of atoms called elements, but the periodic table can be divided into 3 main sections. On the left side of the periodic table, we find the metals. They're always found on the left of that zigzag line, sometimes called the staircase, and usually either shaded in with a darker line or in red. Most metals are shiny solids at room temperature. Most are good conductors of electricity and heat as well. Non-metals are found on the right side of the periodic table. So they're always to the right of that zigzag line. Most are gases or brittle solids at room temperature. And most are poor conductors of electricity. Now, there's some special elements that kind of bridge that staircase line. They touch the staircase line, and they're called metalloids. They're found near the zigzag line, and they have properties of both metals and non-metals. They're mainly solids. Some of them have luster. The only one is, the exception to this rule, is aluminum. It's always a metal. So even though aluminum touches that zigzag line or that staircase line, it always behaves like a metal. So those are the 3 main groups that the periodic table can be divided into. I usually tell students if they forget what side metals are on, just find something you already know as a metal, like silver or aluminum or tin. Find that on the periodic table and look at what side of the zigzag line is on. You're always going to find that your metals like gold or silver or copper are on the left-hand side, so that side is the metals. So in addition to those 3 main groups, the periodic table can be organized into periods, which we talked about those being the rows, the horizontal rows on the periodic table. So periods kind of run left to right, and families are vertical columns. They run up and down. So if we look at the periods, those are the horizontal rows. Again, I know students sometimes forget which way horizontal and vertical is, but horizontal runs left and right. Each period is numbered from the top of the periodic tables, okay, so starting at row 1. So period or row 1, okay, so I'm just going to write it in up on this periodic table, only contains the elements hydrogen and helium. Period 2 starts with lithium and will end with neon, okay? So there's 7 periods in total, so we can keep numbering them 1, 2, 3, 4, 5, 6, 7. Now you might wonder why there's these couple of little lines on the bottom, these extra ones, and say, Mrs. Nelson, isn't there periods 8 and 9? Well, no, if you look at the color coding on this periodic table that I've put up on the right-hand corner, they're actually the same colors as rows 6 and 7. So because our periodic table is kind of too wide to fit nicely on a piece of paper, we actually pop those groups off. They're called the anthenide and the lactonide series, and they just run along the bottom, but they're actually part of periods 6 and 7. So there's 7 periods in total. Don't forget about that row 1. Lots of students want to forget that row 1, that period 1 has hydrogen and helium in them. And again, when we drew our Bohr models, we talked about the periods or rows, that tells us how many rings or orbitals are required when we're drawing our Bohr models. Okay, families, also known as groups, that means the same thing, are vertical columns on the periodic table. So again, that's running up and down. So it's most helpful to us to number our tall columns 1A to 8A, or 1 to 8. So tall column 1 just above kind of lithium and hydrogen, tall column 2 just above beryllium, 3 would be just above boron, 4 above carbon, 5 above nitrogen, 6 above oxygen, 7 above fluorine, and 8 above kind of helium. Okay, so those are numbered 1A to 8A. Those are the tall columns. You'll often hear me call them the tall columns. Okay, so those are the taller columns. And that tells us how many electrons are in the outer shell when we draw our Bohr model. So if it's in tall column 1, it's got 1 electron in the outer shell. If it's got tall column 2, it's got 2 electrons in the outer shell. Tall column 3, 3. 4 has 4 electrons. 5 has 5 electrons in the outer shell. 6 has 6. 7 has 7 valence electrons, because remember, valence was our term that we used for those outer shell electrons. And as a rule, family, or tall column 8 has 8 electrons in the outer shell, with the exception of helium. It's put in that column, that tall column 8, because it's got a full outer shell, and so do the rest of them in that group. But remember, helium is full with just 2 in that first shell, because it only holds 2. So these short columns, the ones that are kind of in white here, these could be numbered 1B to 8B, but we're not going to really deal with them. They've got a wide variety. They're called the transition metals, and they've got a wide variety of properties, and you'll see those more in grade 10 science. But common properties are most often found in families. Okay, so lithium has similar properties to sodium, which has similar properties to potassium. So by knowing what element a family belongs to, or by knowing what family an element belongs to, pardon me, you can know certain information about it. So you are responsible to know some of the families on the periodic table. Okay, and they're actually, if you look at the periodic table you get to use in class, they're all labeled for you. Those labels would come off on a test. But you need to know the alkali metals, tall column 1. So this is lithium, sodium, potassium. They're very reactive metals. They're the most reactive metals. They have 1 electron in that outer shell, or 1 valence electron. Tall column 2, the alkaline earth metals, are reactive metals. They're not quite as reactive as their neighbors, but they're fairly reactive. They have 2 electrons in the outer shell. Then we're going to skip all the way over to tall column 6. This family, the oxygen family, is called the chalcogens. They're now nonmetals. They're found to the right of that zigzag line. They have 6 electrons in their outer shell. Their neighbors, the halogens, tall column 7, are the most reactive nonmetals. Okay? They have 7 electrons in their outer shell. And the very far right column, noble gases, these are nonmetals, and they don't react with other elements in nature because they have a full outer shell. So they have 8 electrons in the outer shell, with the exception of helium, which is full with 2. So take a second, pause your video, and compare this periodic table with the one I gave you, and we'll label it